So for FRQ number 3, we've got a small mass. Oops. Let's get this. The small mass of 20 kilograms is attached to a horizontal spring with a spring constant K, and on the other end of the spring is fixed to a wall when a block is 0.1 meters from its equilibrium. This is its speed. So we've got a lot of information here. We want the total energy of the object, which in this scenario, it's on a horizontal surface, so we can say that the gravitational energy stays constant, and that's 0. But we've definitely got some speed, so kinetic energy, and we've definitely got a spring, so spring potential energy. And the equations for that are here. And we do have all the values for it, so this is just simple algebra. And delta x is 0.01 squared. You can plug that into your calculator. It all comes out to 0.026 joules as the final answer. For part B, we've got the max displacement of the object from its equilibrium position. So that's when if we have the block on a horizontal surface, that's when the block is stretched to its maximum position. And if this is our equilibrium, then at that point, that would be when the block is momentarily stopped. And so the velocity is equal to 0 at that point. And all of the energy would be the elastic potential energy. So we know the total energy is equal to 0.026, and since there's no kinetic energy, then all we've got is elastic energy. So 0.026 is equal to 1/2 k delta x squared. We know k is 200, which half of 200 is 100. So I'm going to divide 100 on the other side, and since this is delta x squared, I can take the square root, and I end up with delta x is equal to 0.016 meters. So for part C, I'm going to use the same diagram. We know that the max elastic energy is at the maximum stretch, and that the velocity at that point is 0, but the velocity would be maximum when it goes through equilibrium, which means that's going to be the point where the elastic potential energy is 0. So we're going to take E total is equal to, this time we have all kinetic energy, my elastic energy is 0, and so 0.026 is equal to wrong equation. Mass times velocity squared, and my mass is 0.2. So if this is 0.2, divide that by 2, it's 0.1. And then I've got velocity squared is equal to 0.026 divided by 0.1, which is 0.26. If I take the square root of both sides, I end up with a velocity of 0.51 meters per second. So for part D, it says find the location of the object where its kinetic energy equals potential energy. So there's two equations that go into this. First, the total energy is kinetic plus elastic. The second is that kinetic is equal to elastic. Since we're trying to find the location, which is delta x, we want to avoid using kinetic energy. If kinetic energy is equal to 1/2 k delta x squared, then I can substitute this equation in here, and that gives me E total is equal to 2 times the elastic potential energy. And then I've got this, which cancels out. My total energy was 0.026 is equal to K, which is 200, right? 200 delta x squared, and then I can solve for delta x, which is the square root of 0.026 divided by 200. And that would give me 0.011 meters.